So you're probably wondering, what is this? What is this bug-eyed character? Well, what I did in other videos actually showed how we can swap character models, and what we did is actually we took one of the end of the game cinematic models, which is shown at the end of Tina's story. And so this is Tina when she was younger, and typically you wouldn't be able to play as young Tina, and you can probably see why. So how the game works is you have all these characters here in the select screen. When you select a character, a skeleton is applied to all of the costumes in the list. Okay, so I call these different characters slots. So I would say Kazumi's slot, you can put anything you want in there, right? You can put other Kazumi models in there or other models in there. But if you swap different models in Kazumi's slot, Kazumi's skeleton will be applied to whatever you put there. And so the effect is you get a deformed character. So perfectly fine if you're swapping, you know, Kazumi models within her own slots, or in her own list there, in her own slot. And I think one of the other demonstrations we did is we took Helena's end of the game, not end of the game, but one of her costumes during her story mode, which is her opera dress, and normally you can't play it, and so we brought that in here by just replacing one of her normal costumes with that, and it looks fine because we are exchanging a Helena model with a different Helena model. But because we swapped one of Kazumi's model with a different model, the model actually wants to stretch to, you know, kind of conform to her skeleton. And so what I did is I said, you know, we can fix this, but it's gonna be freaking hard. Okay, so in this video I'm just going to show you how we can fix the skeleton. And basically what we're going to do is we're going to go into a hex editor, and we're going to do a lot of manual hexing, and so it's going to be really difficult. What we're going to do is we're going to force the game to actually accept a skeleton. Oh, actually, this is actually another funny one here too. This is actually Brad Wong from Dead Alive 3. Thanks to Bonnie, he actually was able to put him in the game, but that's another topic. That's actually not supposed to be there. I didn't actually mean for that to be there. Anyway, so yeah, what we're going to do is we're going to fix this. And here, I'll show you one example. I'll show you the example that I did here. This is young Tina with the fixed skeleton. The only problem I see is the eyeball seems to be on the wrong object, or wrong skeleton or whatever. But other than that, the eye thing, actually, come on, go back in there. Okay. Other than that, you know, she seems to be doing not too bad. She's a little bit floating above there. Okay, my controller is like really screwed up here. Alright, so yeah, basically we're going to do some hex editing so that we can get this end result with Tina, or for that matter, fact of the matter, any other character model that you have this issue with, because you might be trying to do something like, I don't know, like putting like Leon over Kazumi, or Kazumi over Leon, or something like that. And so you'd have to do the same thing. Okay, so this is annoying. My controller keeps dying. Let's get out of here. Die, just die. Go away. What we need to do is grab the files from the disk, and so what we need is the data DVD to get young Tina off the out of the archive. We'd also need the data HDD2, which we would need to put young Tina into, because these are where the selectable characters are. And then we need the executable, which is the DOA XBE, which will have the skeletons that we have to copy into our modified model file. Okay, data HDD is included here as well, but it's actually stage models. I brought that here for something else, but you can ignore that. We're not going to actually use that. Application-wise, we're going to be using file resize. We actually need, well, I guess you could use GreedXplorer for like navigation and previewing things in the data DVD and the data HDD2, just to get an idea of where things are and where you want to put things. But other than that, you're going to need a Ninja Toolbox, which is here, Ninja Toolbox, and this is to manage the archive. And the other tool is a hex editor, and I'm going to be using WinHex. Okay, so first let's unpack the files. I've already unpacked the data DVD. Let's unpack the data HDD2. Okay, so we're going to extract all. Desktop, new folder, data HDD2. Okay. Yeah, that's the original one. Okay, so where'd the folder go? Here it is. Okay. So just a reminder about repacking. Ninja Toolbox will extract the files raw from the AFS file. So the files that we get are actually locked. They're encrypted, and you can't really do much with them. The only thing we can do is actually just rearrange or manage files if we want to swap costumes or characters or whatever. Okay. What we're going to be doing for this demonstration is we'll insert. Who do you guys want to do? We'll put young Tina on Bass. That would be hilarious. Okay, we're going to replace Bass with Tina. So we're going to find young Tina in here, and she's YTI for Tina. And what we're going to do is just rename these the Bass and then drop those in there. So that's kind of easy. Copy. Okay, so now let's rename these to Bass. 00. Now the XPR is the geometry and the textures, and the cat file is everything else. Physics, morph targets, whatever you name it, it's in there. But the cat is actually missing the skeleton, so we need to put the skeleton back in there. This we can put in here. We're going to move it and replace. Okay. This one here, we're going to have to increase the file size, so I'm going to use this little tool called File Resizer. I'm going to open up this file here. So the cat needs to be resized because it's going to be receiving a new skeleton. If I can find it, holy crap. There it is. Alright, so you can see in here we have the original size, and we're going to want to increase it. And let me just find the calculator. Okay, calculator not here. Calculator. Okay, so you might get different style of calculator depending on your version of Windows. This apparently is the Windows 10 one. Which reminds me of the Windows XP version, which I really liked. But anyway, doesn't matter which version of calculator you have, you should be able to go to View and change it to Scientific. And then from there you'll have the option to change the units or the base units from hex, dec, occ, and bin. And so this is important. So right now we're given a decimal representation of the file size. What we're going to do is we're going to type that in. Actually, wait a minute. What's the... We need to add a certain amount. I forgot what the amount was. Okay, it's 392 in decimal, sorry. So yeah, so we're going to go 30388 plus 392. Okay, so this is the new file size that we need to type into here. Okay, so 30780. Okay, so 392 is the additional size of the skeleton. Now, all of the skeletons are the same size with the exception of Tengu, so you can use that number 392 for all of the models except if you're going to apply a Tengu skeleton, I guess. I think. I don't know. Alright, so we're just going to go, and it should write a new file with the letter X appended to the file name. Okay, and I guess we can just minimize that for now. We can delete the original one, and we're going to rename this to the proper name. And so now we're going to put this into here, move, replace. Okay, so right now the cat is basically invalid, but that's not really really important right now. We're going to rebuild this. So I'm going to close this. We're going to go to import now. I'm going to select the folder that came out of, which is the data H82. Specify a new file. Let's see here. Do I have the old one here? No. Okay, so we just call this new file. Import. It's going to create that thing. Now, what I'm missing is actually the decrypted version of Tina's cat file. So I'm going to grab it from the data DVD again. So where is it? So I'm going to export it, but I'm going to decrypt it when I export it. I'm going to put that to the desktop. Okay, awesome. We can leave this open because we're going to have to insert this later on. Wait, actually no. We need to open up the other file. No, we'll do it later. I'll just put this aside for now. Okay, so this file we need to hex. So we're going to bring this into our hex editor. And we need the executable, which is the DOA EBE. Excuse me. Alright, so Let me first explain a little bit about the hex editor. I'm not going to go into too much detail. Basically, the hex editor is displaying the ones and zeros in the file, and it displays it so that we can kind of see them in an organized fashion. Now, it's just a viewer like it was just viewing like a text file or something like that, and the numbers still won't make any sense. So what it comes down to is understanding data structures, and we already know the data structure, so what we need to understand is how to interpret the values. So you can see here we have a value that looks like 20 and a bunch of zeros. Okay, you have to imagine that the computer doesn't really care if it reads from left to right or right to left. So in this case, we call this a little endian representation, where the numbers are actually represented backwards. So let's see here if I can just get a little text me here. Here I got like notepad here. Okay, so to you, if I wrote this, you would interpret this as the number 2. Okay, this would actually be represented in here actually maybe 20,000 or something like that. So in this representation, when it's typed in like this, it's not like not 200 million or something like that. It's actually 20. So you're reading it backwards. So the zeros are just ignored. So you kind of have to get in the habit of reading it from left to right and interpreting it that way. The other thing is it's in hexadecimal, so if you want the decimal representation, there's a data interpreter here that will interpret it, and it's based off of bits, right? So if I just highlight, this is a single byte. This is 8 bits. 2 bytes, 16 bits. 3 bytes, 24 bits, and of course 4 bytes is a 32-bit long integer. So this file is going to be all 32-bit long integers, so that means I'm going to highlight groups of 4 bytes, and that will be a single value. For example, this is 32 as a 32-bit. So whenever I'm going to a value, it's going to be in a chunk or in a group of 4 bytes. So it should be pretty easy. As long as you understand that these are values in groups of 4, then you should be fine. Okay. Now, there's a way we can represent this to make it more legible, I suppose. And what I'm going to do is I'm only going to highlight as much as I need, and then we'll flip it. So let me first describe how we can understand how this thing works. Okay. So these groups of 5 integers are the header, so they describe the entire file. So this first one is saying the version number, because you could be in Dead or Alive 2 Ultimate or Dead or Alive 1 Ultimate, or you can be in Dead or Alive Extreme Beach Volleyball. So that's a version number, and so 20 or 32 represents Dead or Alive 2 Ultimate. The next the 4 values are actually addresses to a set of unique data. So the only data that we're interested in is 14. So if I go to offset, I type in 14 from the start of the file, it's going to bring me here. Okay, so that's the first set of data. It's pretty easy. The second set of data is, what is that, 190. And this brings us just about here. Okay, so what does that mean? That means this block that I've highlighted here is the first chunk of data. So what we need to do is insert the skeleton in this chunk. But by doing that, we're going to push all these other chunks down, and so we have to basically recalculate all the offsets or addresses that are printed above it. So it gets a little bit complicated. What are you doing, buddy? Somebody lock you in my room? Why would they do that? You know, you gotta stay in here. Okay, so so this is the 4 addresses here. This is the first block. So the first block has its own structure. So the structure is, again, format. This is like a version, and then I'm not sure what this is, but I'm just assuming it's all version. And then after that, we have a table. So the table has entries in it, and they're in sets of 2 long integers. So we can see here it's giving us an address, a new address, and a code. So this code is an identifier for the type of data that's in there. So that's at this address, you'll see a type 1 data block. And then we have a second entry saying at this address we have a type 3 data block, and so forth and so forth, repeats. So we actually have a total of 1, 2, 3 different sets of data blocks in there. That's inside of this first block thing. Once we reach a set of 8 bytes of zeros, the table is assumed to be terminated. So all we have to do is insert a new entry. So what I'm going to do is I'm going to copy this set of zeros and then just paste them at the beginning. So how I'm going to do this, I'm going to go to Edit, Copy Hex Values, which is Control-Shift-C. I'm going to go to the beginning of that, and then go to Edit, Clipboard, and Paste. Okay, that's Control-V. Yeah. Okay, so everything turned blue down below the file because it's been modified. So anything that's in blue is modified. So you can see everything below the file is showing shifted or modified. So okay, so now with this new entry in here, this new blank, we're going to have to write in some of the data. So the address is now, well, let's first paste in the skeleton actually, and then we'll explain that. So in the DOA2XBE are the skeletons that are shared to all the characters, and I have compiled a list, if I can find the list. Let's see here. Oh, you know what? I probably just have it here. Yes, I do. Okay. Alright, here's the list that I compiled. Unfortunately, I can't confirm that this is going to be compatible with all regions of the game, because I think there's like 3 major regions. There's probably the Japanese, European, and North American version. So I live in Canada, so I'm assuming mine is the North American version. And these are the offsets that I compiled for my executable, but I don't have a Japanese copy or European copy to actually confirm that information with you. So sorry. I do have the files that were separated from the executable, but sharing that would be kind of a copyright infringement, and well, at least it might be. So I won't be sharing that stuff on the YouTube channel, but I'll be putting this up because I don't see how that's illegal. That's just telling you where to read it from. So what we're going to do is we're going to grab the file for young Tina directly from the executable. So this table is going to tell us where it is from the executable. So we're looking for young Tina, which is here. So her offset is this thing. So I'm just going to copy this, and I'm going to go into the executable. I'm going to go to the offset and paste that. And for this thing, I've actually colored the ranges to make it more, I guess, more apparent. So anyway, this range here is young Tina's block. So what I'm going to do is I'm going to copy this block. So it's just going to be copy block, hex values. Then I'm going to go back into here. Okay, so now that we have the skeleton, what I'm going to do is I'm going to insert it. So again, let's try to understand this. So we've added an extra entry to the table, and the next 8 bytes are the terminator code, and then it starts to go into the actual data. Okay, so what we're going to do is we're going to paste the skeleton here. So we're going to paste it right here, and that was Control-V, so that's pasting. And the table has now been inserted, and the rest of the data has been bumped down. Okay, so the wait a minute, and then Okay, so this position here, if I highlight, you can see in the bottom right, it's telling me what I've highlighted. You know, depending on what I highlight, it'll tell me what I'm highlighting. So that's the new entry. That's the blank. Okay, that's the start. So the start is at 44. You can also see it in the grid pattern here. We're at 40 and 4 here, so 44. So we're going to take the value 44. So we're going to take our calculator, convert it to hex, type in 44, and we have to subtract the address of that first block, which is 14. So minus 14, and it comes to 30. So in all cases, it'll usually be 30. Actually, that's a lie. I don't know if it'll always be 30, but it'll be close to 30. So we're going to type in to our new entry. We're going to type this into our new entry now. So for here, we're going to type in 30. That's the address. And then the type is going to be type 8. We're going to type in 8 here. Okay. And I actually forgot to explain how you can make this simpler for yourself, actually. Yeah, what you're going to do is you're going to highlight a range that you want to flip. You know, flipping it makes it easier for you to read. And I don't know if this is universal to all hex editors, but in this hex editor, I can go to Modify Data, and I can do a 32-bit swap. And that swaps the ending from little to big. and so now it becomes legible to what normal people are used to, so the numbers look more natural, I guess. I want to keep it this way to make it a little more simpler for you guys, because I'm comfortable reading and writing from left to right and right to left. But the thing is, if you make a mistake here, it'll crash the game, and then you're going to have to redo the entire thing. So we want to make this as easiest as possible. So for the parts of the header here, I guess these like 4 rows, I've swapped them so that we can do the math easier. Okay. So now this is already done. We're done with that. Everything above this has to be recalculated now. So we're just going to use a calculator. That's the easiest way to do it. So we don't have to change the version. We don't have to change the first block offset. But everything after that we do. So I'm going to copy this, and I'm going to use my hotkeys now, because if I keep going through here, it's going to take forever. So again, I'm just going to use Control Shift and just Control Shift for now. So Control Shift C for copy. I'm going to go into my hex editor. I'm going to do Control V to paste. Again, I'm in hexadecimal mode, and I'll get a value here which is 190. Okay, so the total size of this thing, I'll just tell you, it's 188 in hex. So all you have to do is add 188. So we're going to go plus 188. And that's the final hex value that we have to type back in. So 318. So we're going to type in 318. Then we're going to copy this one. Plus 188. 344. And so forth and so forth. It's kind of easy. So plus 188. 2BE8. If you're wondering if you can just copy and paste between the calculator and the hex window, I can. It's just in the WinHex it's a little more complicated than I would like it to be, so it's actually easier for me to type it in. (1BO). Okay, and that's it. All right. We just have to remember, because we swapped the header, we have to re-swap it back so it's in the correct endian. So I'm going to do another 32-bit swap, and it's now back into little endian, which is the way it should be. That means the value should be more on the left side. Okay, so just make sure before you decide to save and all that, just make sure you double check all your work. I had to change again the second block, the third block, and the fourth block, and then everything in the subtable here, the entry for number 1, entry for number 3, and so forth and so forth. So should be it. There wasn't many entries there, so it seems to be okay. So I'm going to save now, and we're going to inject that back into the what do you want to call it? The AFS. So we created the new file. All we have to do is replace the cat file now. So we're going to go back to cat, and I lost it. Who did I swap it with again? I think it was Bass. Yeah, it was Bass. So I'm going to right click on this. I'm going to go to import with encryption, and I lost it. Here it is. Okay. Now, if there's an error, that probably means you have to resize it. So you have to go back to the beginning and resize it. Try to resize it again to make it the correct size. Okay, because if it gets bigger, you can't insert it. So just keep that in mind. In this case, it says it's perfectly fine. It wrote back fine, and then we're good to test it in the game now. So I'll close it down, and I'm going to copy the new file back into our directory here. Copy. Okay. When you're replacing your data HTTP2 with a different file, just make sure you make a copy, because Ninja Toolbox is actually really terrible for creating and resizing files. It could crash, and it might not be because you made a mistake. It could be just because Ninja Toolbox just decided to be an asshole, so make sure you make a copy, so you can always go back. And we're going to boot it up and see how it goes. Okay, so this is the moment of truth. Oh, it didn't crash. Nice. Oh, that's awesome. Ah, why is he there again? That's so awkward. Oh, he screwed up too. Anyway, it's simple, easy, as long as you don't get too confused during the hex editing. It's not as daunting as it actually is once you can figure out the structure and the logic behind it. It's actually quite easy. But you know, it would be nice if there was a program. So, hint, hint. If there's a programmer watching this, feel free to make up your own little program there, because much appreciated. Ooh, that's hilarious. Too bad the eye is screwed up. We can always fix that, with vertex editing or something. Okay, that's it. Thanks for watching, guys, and good luck with the modding.